Welcome to True Projects. In this video, we are going to explain about a project titled Carcinoma Type Classification from High Resolution Breast Microscopy Images using a hybrid ensemble of deep convolutional features and gradient boosting tree classifiers. Breast cancer, a condition primarily affecting the woman but occasionally men, manifests through the symptoms like breast lumps, nipple discharge, and alteration in nipple or breast texture. The cancer treatment varies based on its age. Emphasizing the timely detection, distinguishing between the normal and the malignant tissues is crucial. The conventional histopathological assessment of biopsy samples reliant on manual scrutiny by pathologists proves time intensive and diagnostically inconsistent. Previously, nuclear segmentation and the mitosis recognition were manually employed for feature creation in histopathology images, classified via traditional machine learning. However, the emergence of deep learning, particularly CNN, and the realm of computer vision has revolutionized the breast histopathology image classification, enabling the more advanced and accurate analysis. Our project involves creating a highly accurate automated system to classify the histopathological images for diagnosing the breast cancer. Our innovative approach employs a hybrid ensemble framework harnessing the power of finely tuned convolutional neural network architecture as adopt the feature extractors. These CNN work in the tandem with the extreme gradient boosting tree which act as the proficient top level classifier. This ensemble model excels in patch-wise classification of intricate high-resolution breast histopathology images by amalgamating the diverse and the discriminative feature representation of parts, and bolstered by the robust classification capability of XGBoost. Our method aims to substantially enhance the precision and the reliability of patch-wise classification, thereby advancing the accuracy of breast cancer diagnosis. And these are the basic requirements that are needed to build this project. That are software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. In this step, we need to import the libraries and modules required for the entire process. Commonly used packages include TensorFlow, Keras for the deep learning, OpenCV for image processing, sklearn for the machine learning, and the Flash for web application development. And the second one is exploring the dataset. Here, the dataset of high resolution breast microscopy images is loaded and explored. This includes checking the size of the dataset, examining the sample image, and understanding the distribution of different carcinoma types. And the next one is image processing. Before feeding the image into the model, pre-processing steps are applied. This involves resizing the image to a consistent resolution, normalizing the pixel value, and possibly applying the image augmentation technique like rotation or flipping to increase the model robustness. And the next one is data extraction from the image. In this context, this step involves extracting the relevant information from the images. This includes by identifying the region of interest, such as specific structures or the pattern within the breast tissue. And the next one is splitting the data into the training and the testing set. The data set is divided into the two parts, the training set and use it to train the model, and the testing set use it to evaluate the model performance. This division ensures that the model effectiveness can be properly assessed on the unseen data. And the next one is building the model. Various deep learning models are constructed using the various architectures, and the first one is Inception V3. It is a deep convolutional neural network architecture that excels in image classification. Its distinctive feature is used to multiple filters of the different sizes within the same layer, allowing it to capture the features at the varying scale. And this project, Inception V3, is one of the models used for the training. It learned to recognize the complex pattern and the structure within the high resolution images, enabling it to distinguish between the different carcinoma types based on this learned feature. And the next one is VGG19. It is also a deep learning neural architecture known for its simplicity and the effectiveness. It consisting of the 19 layers, primarily using the small 3x3 convolutional filters. VGG19 is employed in the project to extract the features from the breast microscopy images. Its straightforward design and relatively smaller kernel size make it adept at identifying the texture and the finer details in the images, contributing to the accurate carcinoma type classification. And the next one is MobileNet. It is designed for the efficient computation on the resource constrained devices, making it well suited for this project. It employs the depth-wise separable convolution to significantly reduce the number of parameters while retaining the strong feature capability. And the next one is Inception ResNet V2. Here it combines the elements from both the Inception architecture and the residual network. It incorporates the residual connection to elevate the vanishing gradient problem and facilitate the training of very deep networks. In this project, Inception ResNet V2 plays a crucial role in the feature extraction from the images. Its ability to capture both the local and the global feature aid in identifying the intricate pattern indicative of the different carcinoma types. And the next one is ResNet 101. It is a deep residual neural network with the 101 layers. It is designed to enable the training of extremely deep networks without suffering from the vanishing gradient issue. ResNet 101 is utilized in the project to leverage its depth and feature extraction capabilities. It learns to discern the key characteristics of the images that differentiate between the various carcinoma types, contributing to the accurate classification. And the last one is XGBoost with CNN. It is an ensemble learning algorithm that combined with CNN in a hybrid approach. While CNN are proficient at feature extraction, XGBoost serves as a high-level classifier, making the final prediction based on the features extracted by the CNN. This combination enhances the model's overall performance as XGBoost leverages the deep features to make the refined prediction, ensuring the robust and the accurate carcinoma type classification. And the next step is user gives the input. Here, a user interface is created using the Flask where the users can input an image for the carcinoma type classification. This input is processed and prepared for the prediction. And the next one is the given input is pre-processed for prediction. Here, the trained hybrid ensemble model takes the pre-processed input and process it. The trained model is used for the prediction for the about image. The trained and the pre-processed image is predicted on the trained model for predicting the carcinoma type of this breast cancer image. And the last one is final outcome is displayed through the front end. Here, the final outcome is displayed on the front end of the web application, indicating the predicted classification of the given image. This system aids in rapid and accurate identification of different carcinoma types, facilitating the timely medical decision. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The sample folder containing of the images that will be used to test the performance of the model, and the static folder containing of the folders like assets, JavaScript, CSS, uploads and images within it, and the template folder containing of the HTML documents. It typically include of graph, home, index, sign-in and sign-up pages within it. An app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handles the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains the combination of the code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appear to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and paste this code folder path. By this it will change the current directory to the code folder path, and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on the enter button. Here the app.py file will run and the Flash framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. We can see some information on the title of the project, and then click on the login button. Here it will redirect to the login page containing of username and the password, and we need to fill those details of username and password and then click on the login button. Here it will redirect it to this page containing of the choose file and upload button, and click on the choose file button. Here it will redirect it to the sample folder containing of various images within it. I'm selecting one image and then click on the open button and then click on the upload button. Here it predicted the image as having the carcinoma type is invasive, and by using the try again button we can redirect back to this page and then can choose another files too. So click on the choose file button and then select one image and then click on the open button and then click on the upload button. Here it predicted the uploaded image is of normal. In this way we can differentiate the carcinoma type by using the various deep learning models. And in conclusion, the novel hybrid ensemble framework for the breast cancer image classification with the objective of improving the patch-wise classification with fine-tuned different CNN architecture for extracting a variety of discriminative feature representation from an input patch. For the classification of extracted features, incorporating the XGBoost classifier result in better classification performance compared to the traditional softmax.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.